Hello friends, in this video I'm going to show you how to solve this Legendre's differential equation. This is the equation here. So please do subscribe the channel, hit the thumbs up button, also share with your friends, inspire me to create new contents for you and help me to grow my channel. And if you see the hype button below the video, okay, then please do hype the video, right, so that it reaches to maximum audience. Okay, so now let's start. And one more thing, if you want to follow me on Insta, this is my Insta ID, OJHALAKHYAJIT123. That's my Insta ID. You can follow me on Insta if you want to follow me. Okay, so now let's start. So here is the Legendre's differential equation. This is the Legendre's differential equation. Okay, so now you see I have taken this one as equation number 1. So this equation, a solution of this equation can be expressed or can be obtained as a as a series of ascending or descending powers of x. Okay, and let me consider a series of that kind. Let me consider a solution. For the solution in series of descending powers of x. Okay, for descending powers of x, let me consider y is equal to summation r is equal to 0 to infinity ar x to the power m minus r. Okay, if you want to find the solution in the form of a series of ascending powers of x, then instead of x to the power m minus r, you have to write m plus r. Okay, that's it. Okay, now you see, if you expand this series, if you write this summation in expanded form, so you're gonna have this series. Let me write this one. Okay, so now let me take this as equation number 2. Okay, let me write this as equation number 2. Okay, so if we differentiate both sides, then dy by dx, then here you see ar is constant term. Okay, if you differentiate this x to the power m minus r, then what you're gonna have m minus r into x to the power m minus r minus 1, right? Hope you have understood this. That means just simply we have applied ddx of x to the power n, which gives n into x to the power n minus 1, right? Here m minus r is the n here. Okay, consider that way. That's it. Very simple, right? Hope you have understood this. So now you see, okay, now let me differentiate it again. Let me find a second order differential, the second order derivative. If you differentiate it again, both sides, okay, second order derivative of y with respect to x, then again if you apply the same formula, then you're gonna get summation from r is equal to 0 to infinity ar, now m minus r. Now this time power on x is m minus r minus 1, so that's why here we're gonna have m minus r minus 1 into x to the power. Again reduce the power by 1, so we're gonna get m minus r minus 2. If you subtract 1 from here, then you're gonna get m minus r minus 2, right? So now let me use these results in equation number 1. Okay, if we use these results, if we put the value of y dy by dx and second order derivative of y with respect to x in equation number 1, in this equation number 1, then what we're gonna have. So now you see what I'm gonna do here. Using these results, these equations in equation number 1, we're gonna have, let me write here. Okay, first let me write here what we have got. Okay, after using this value, then I'm gonna explain it again. So this and just give me a second, just wait. Okay, here you see. Okay, first let me write this here. Now I'm gonna explain. Okay, so now here you see what we have done here. Let me write it properly. So first, this is replaced by this result. Okay, you can see right? Okay, then this dy by dx is replaced by this result. Okay, then this y is equal to, that is replaced by this. Hope you have understood this, right? So now what we are going to do, and using those results in this equation number 1, we have got this equation. Okay, let me take a new slide. So here is the last step that we have got in the previous slide, that I have written it again. So now if we simplify this, then what we're going to have, so first let me open this bracket. Then what do we need to do? We need to multiply this whole term by 1. Then again we need to multiply this whole term by this x square, and between those two we're going to have a negative sign here. Okay, first multiply this part with multiply it by 1. Okay, multiply it by 1, then put the negative, then again multiply it by x square. Okay, so hope you have understood this. Then doing so, what we're going to have, just give me a second. Okay, so let me write. So 1 into summation r ar m minus r into m minus r minus 1 into x to the power m minus r minus 2. Okay, now minus, here we have put minus, then multiply this term by x square. Then what you're going to have, if you multiply it by x square, then you see this is x square, that means x to the power 2, and if you multiply this power is positive, so positive 2 negative 2 will be cancelled, right? Hope you have understood this. So first multiply this two, let me write this one. Okay, let me multiply this one. Okay, let me write this, x to the power m minus r. Okay, so on when this is multiplied by x square, this power is positive here, so plus 2 minus 2 gone, so we have got this, right? Hope you have understood this. So now let me simplify further. So here you see one more thing, if you multiply this x with this, then here we have power 1, here we have power 1, this minus 1 plus 1, that's going to be 0 again. Okay, so then what we're going to have, then we're going to have this. So now x is multiplied already. Okay, so now let me write this term as it is. Okay, so let me write that one here. So this is what we have got, right? Okay, so now what we can take common. Okay, so now let me simplify it first, then I'm going to explain what I have done. Okay, first let me write the result after simplifying this step, what I have got here. Let me write this one first. Okay, so this is what we're gonna have after simplifying the above step. So now here you see, here we have ar into x to the power m minus r, and here also we have ar and x to the power m minus r, and in this term also we have ar x to the power m minus r, and here we have taken this x to the power m minus r common. This term is taken common from these three terms, this one, and this one. From these three terms, what we have done, we have taken this ar common, and this term, actually I have taken this part common. Okay, that's what I have done here, and then within bracket we're gonna end up getting this one here. Then after taking this one and this one common, this part common, then we have got minus 2 m minus r. This is what we have got here, you can see. Then from here this part is taken common and this part is taken common, so we have got this part within bracket here with this minus sign. Okay, so hope you have understood this. So now let me go to the next slide and let me copy the last step. I'm talking about this step. Okay, and let me go to the next slide. So here you see, So this is the last step. Let me rewrite the last step again. So here is the last step, what I have got in the previous slide. That's what I have written it again. So now you see, okay, so here what we can do, so how to simplify this. Now first let me simplify this part. Okay, so here what we can do, so this term within curly bracket will become this n into n plus 1. Then you see, let me take this part common from these two terms. From these two terms we can take minus m minus r common. Then within bracket we're gonna have this minus 2. As minus is already taken common, this minus 2 become plus 2, right? Then this minus is already taken common, so here we're gonna have plus m minus r minus 1, right? So this is 2 minus 1, so it's gonna be of this form, n into n plus 1 minus m minus r, m minus r plus 1. That's what we're gonna have, right? So hope you have understood this. So let me write it now. So what we have got here, so this equation gonna be equal to of this form. So here I have done one more thing, this part is taken common, right? So then it will be of this form. Okay, so this is what we have got, right? So now this is equal to 0. Okay, let it be equation number 3. Okay, now from this equation number 3, what we can do, we can equate the coefficients of x to the power m. Okay, putting r equal to 0. If you put r equal to 0 here, you're gonna get x to the power m, right? So if we equate the coefficient of x to the power 0 on both sides, we have no term on the right hand side with x to the power 0. So that's why coefficient on the coefficient of this x to the power, sorry, not 0, x to the power m, I'm talking about x to the power 0, x to the power m, that can be obtained by putting r is equal to 0. Here we have r, so if you put r is equal to 0, this will be x to the power m, and its coefficient, the coefficient on the left hand side of the term, x to the power m, that will be equal to 0, because on the right hand side we have no any term with this containing x to the power m, right? So that's why we can consider the coefficient of that is equal to 0, right? Hope you have understood this. So now you see, let me write it clearly. Okay, so now equating the coefficient of x to the power m, so putting r is equal to 0. So why we have to put r equal to 0? Because here you see, if you put r is equal to 0 here, then you will get x to the power m, right? So let me write that way. So to 0, equating the coefficients of x to the power m to 0. So from this above equation, you're gonna have this result, right? So now here you see, if you put r is equal to 0, so this term will be x to the power m minus 2, right? Not x to the power m, only this part will be x to the power m. So here I have taken this part here, and so here you see, as this part is taken common, here this AR should be multiplied with this and this as well. So that's why so AR belongs to this term also, so that's why I have written here AR, and as R is 0 here, so I have written here A0. Now if we consider that the first term of the series is the term containing A0. Okay, suppose we have a series of numbers, suppose y is equal to, suppose A0 x to the power something m n whatever it is, okay, plus A1 x to the power m plus something or minus something, whatever it is. Okay, so if you see, if we take an A0 equal to 0, if you see, if A0 becomes equal to 0, then this term will not be considered as first term, because this whole term will be 0, then first term will be regarded as this one. Okay, so if we consider that this is the first term of this series, then this a naught cannot be equal to 0, then only this term will exist, right? Hope you have understood this. So that's why here I'm going to write that this a naught is not equal to 0, as it is the coefficient of the first term, very first term of the series, right? So we have considered that way. Okay, so therefore if this a naught is not equal to 0, this must be equal to 0, then only we will get 0 here on the right hand side. Hope you have understood this, right? So if we put this one is equal to 0, if we write this one is equal to 0, then what we're gonna have, we're gonna end up getting this. Now here you see, if we simplify this, now let me copy this last step and let me take a new slide, okay, so that I can explain further. Okay, so now you see, if you simplify this, then you're gonna get this result. Okay, so then you're gonna get this result, and from here you will get, okay, just give me a second, let me write this one first. So what we have got here, this is what we have got. Okay, so now let me explain how we have got this. So here you see what I have done here, just open this bracket, then you will get this, right? Then again, if you open this bracket, then that means if you multiply this two, then you're gonna have this, right? So from here what we have done, I have written here n square minus m square. Okay, then n minus m, this is n minus m, right? So this can be written as n plus m into n minus m, right? A plus b into a minus b, algebraic identity. So hope you have understood this. That's very simple. I don't think I need to explain these kind of things for BSc students or MSc students. So this is written in this form. Okay, so hope you have understood this. So now take this common, then I end up getting this. Okay, so from here what we're gonna have, either n minus m is equal to 0 or this part is equal to 0. So that's why we're gonna end up getting this n minus m is equal to 0, or plus m plus 1 is equal to 0. That implies m is equal to n, right? This implies m is equal to n, and this part and this part implies m is equal to minus n minus 1. So which can be written taking minus common, n plus 1, right? That's what we're gonna have. Okay, so let it be equation number 4. Okay, so here I am writing equation number 4, both these two results. Okay, not only for this part. Okay, so hope you have understood this. So now, so what I'm gonna do now, again we're gonna equate the coefficients of x to the power m minus 1. Last time we did x to the power m. Now we're gonna do compare the coefficients of x to the power m minus 1 on both sides. Okay, so hope you have understood this. So now okay, so let me rewrite the equation number 3. Okay, so I don't want to go back to the previous slide, so that's why I have written the equation number 3 here again. Okay, this was the equation number 3 you have already written. Okay, so if you are writing while I am explaining, so don't write it equation number 3 again. It is already written in the previous slide, but I don't want to go back to the previous slide again and again. That's why I have written this equation again. Okay, because we need to use this equation now. So from here what we're going to do, from this equation we're going to equate the coefficient of x to the power m minus 1 with 0. So here you see, in order to get the x to the power m minus 1, we're going to put here r is equal to 1. We're going to put r is equal to 1. So we're going to have x to the power m minus 1, right? Now you see, this power is smaller than this one. Okay, So here if we get x to the power m minus 1 from here, putting r is equal to 1, so then we will not able to get m minus 1 from here. Okay, if you put r is equal to 1, okay, because this power is smaller than this one. Okay, we're gonna take the coefficient of x to the power m minus 1 from here only, not from this term. Okay, so hope you have understood what I'm trying to say. Okay, so now you see, so now equating the coefficients of x to the power m minus 1 to 0. So putting r is equal to 1, so we're gonna have this coefficient, right? We're gonna have this coefficient. This is the coefficient. If you put r is equal to 1 here, then it's gonna be x to the power m minus 1, and whose coefficient is this into ar. Okay, right? So into ar, but here instead of r we have put a is equal to 1, right? Sorry, r is equal to 1, so we are getting here a1 instead of ar, right? So now you see here, from this equation number 4, if you use this result here, then this term within bracket, for this condition and for this condition, for both condition, this part doesn't become 0. You can check it by yourself. First you can try it by putting m is equal to n. If you put here m is equal to n, use this condition first. Okay, here also n. Check if you get 0 or not. If you don't get, I think if you solve it, then you will not get 0. Okay, let me show you how. So if you see, this one will be n square plus n, then minus, here we have to break it. Okay, so then you see, if you put m is equal to n, this is, if you put this m is equal to n, then if you open the bracket, this minus is going to be plus, minus minus plus 1. Then if you multiply it by, again if you replace this by n, then it will be n square into 1 into n is n, right? So that's what we're going to have. This n square cancel, we have got n plus n, that's going to be twice n, so it's not going to be equal to 0. So hope you have understood this. Similarly, if you put m is equal to this result n minus 1, then also if you simplify, that will not be 0. Okay, for these two conditions. So that's why here you see the product of these two will be 0. This is only possible when a1 is equal to 0. Okay, when a1 is equal to 0, right? Hope you have understood what I have explained. So what we can write here, therefore a1 is equal to 0. Similarly, we can show, a3, a5, a7, these are also equal to 0. But here let me write by equation number 4, this part is not equal to 0. Let me mention. Now again, let me copy this equation number 3 and let me go to the new slide. Okay, let me go to the new slide. Then this time we're gonna equate x coefficient of x to the power m minus r minus 2 with 0. Okay, we're gonna equate the coefficient of this term, coefficient of this to 0. Okay, so let me for that purpose, let me write equation number 3 and again. Okay, you don't need to write this again, because if I don't write that equation again and again, I have to come back to the this slide again. Okay, so now I don't want to change the slide each and every time. Okay, so now let me take a new slide. Okay, so here is the equation number 3 that I have written it again. Okay, so now you see, now let me write what I have done, what I'm going to do here, equating the coefficient of x to the power m minus r minus 2 to 0. Okay, so in order to equate this to 0, what we're going to do here, so here you see, so as you can see, we have summation here. Okay, this is not only a single term, this is sum of series of terms, right? So similarly, this one is also a not single term, right? Sum of a series of numbers, series of terms. So here you see this power is greater than this one, right? Clearly it is greater. Here we have -2, right? So as we are taking descending series of descending powers of x, right? That's why from this part, if we keep on writing the terms, we have got this one into x to the power m minus r. So I'm not writing the coefficients here, okay? There must be coefficient, okay? Then next term will be, if you write in descending order, m minus r minus 1, there will be a coefficient, okay? Then again x to the power m minus r minus 2, so here will be also coefficient. So when you equate the coefficient of this term, you have to take this part as well as this part, okay, both, because this series also contain this x to the power m minus r minus 2, right? Hope these things are clear to you. So hope you have understood this now. So equating the coefficient of this x to the power m minus r to 0, we're gonna have this. Let me write it first, then I'm gonna explain here, okay? So this is what we're gonna have, okay? Hope you have understood this. So now you see, so what I have taken here, ar into this, then ar into this, okay? But here don't write the summation here, okay? We are taking the term only where we have got this x to the power m minus r minus 2, okay? So okay, actually this series of number, the summation of this will contain x to the power m minus r minus 2, then m minus, in descending order, m minus r minus 3, and so on, right? So we're gonna taking only this term. That's why we don't need to write the summation here while equating the coefficients of particular power of x, okay? So hope you have understood this. So now you see what I'm gonna do, we're gonna simplify this part, okay? So first, and here you see, in order to equate this coefficient of this equal to 0, here as we have got here x to the power m minus r minus 2, but here it is m minus r, so that's why in this part we're gonna replace this r, by r plus 2, okay? So that's why when you write this ar here, we're gonna write, instead of r, we're gonna write r plus 2. That's why we have got this term here, okay? But here already we have x to the power m minus r minus 2. That's why simply I have written here ar, okay? So hope you have understood this, okay? So now you see, let me write, after simplification, what we're gonna have. First let me write this, okay? Okay, we're gonna end up getting this. So I'm gonna explain how we have got this, okay? First let me write this result, okay? So now you see, so what I have done here, okay? So first let me simplify this part. Here you see, sorry, so this one, okay? Let me copy this part. So here you see how to simplify this. So now just open this bracket, that means multiply n into n square, n into 1 is n, then this part can be written as m minus r minus 1 minus 1. This minus 2 can be written as minus 1 minus 1, right? So that's how we can write. Then into this m minus r minus 1, okay? Now multiply this one with this and this minus 1 as well. So n square minus n, then negative sign, m minus r minus 1, because this one into this one, so we're gonna have a square here, right? Hope you have understood this. Just give me a second. So here we're gonna have a square, then this is minus 1, and here we have minus, so it's gonna be positive, into this m minus r minus 1, right? Now what we're going to do, let me take negative sign common. On taking negative sign common, this positive terms becomes negative, negative terms become positive, right? So sorry, that was positive sign, so here it will be positive, and this negative terms will be positive, and this positive term will be negative, right? So then what we supposed to get, so first let me write this term, okay, which will become now positive, m minus r minus 1 whole square. Then now this n square becomes negative now on taking minus sign common, so let me write here minus n square. Then this term on taking minus, this positive sign will be negative, minus m minus r minus 1. Then on here you see this minus and this plus n will be now minus n, so minus n, right? So now you see, right, what we're gonna have, okay, minus m minus r minus 1. So if you apply a plus b into a square minus b square formula, then it's gonna be this into m minus r minus plus 1, sorry, not plus 1, minus 1 minus n. This is plus n, this is minus n, right? We have applied a plus b into a minus b, a square minus b square, right? Then here you see from these two we can take negative common, so we can write here m minus r minus 1 minus, sorry, it's going to be plus n on taking this negative sign common from these two terms, right? Hope you have understood this. Okay, now you see what we are going to do, we can take this term common, then minus m minus r minus 1 plus n, taking this common within bracket, we're gonna left with this m minus r minus 1 minus n, then we're gonna have minus 1 here. Okay, so hope you have understood this. Now this minus 1 it becomes minus 2, so minus m minus r minus this minus 1 plus n, it can be written this way, plus n minus 1, right? So here we're gonna have m minus r minus n, and minus 1, that's gonna be minus 2. That's what we have got. So this part we have got this, okay, this result we have used here. Okay, hope you have understood this. Now if you simplify this, simply you will get this, right? So if you transfer this term on the other side to find a value for ar plus 2, we will end up getting this, right? Hope you have understood this. Now let me clean these things, okay, so to explain further. Okay, so hope these things are clear to you. Okay, now to proceed further, I need to go back to the previous slide again. Okay, let me go back. So here you see, in this case we have got this part is not equal to 0, right? That's what I have written, and I have got a is equal to 1, a1 is equal to 0. So let me go back to let me come back to this slide. Okay, so now you see, this is equation number 5. As I have already shown a1 equal to 0, let me write this value here, we're gonna need it. Okay, I have already shown a1 is equal to 0. Here you see, here we have shown this is equal to 0. Okay, so now what we need to do is, if you see, if you put r is equal to 1 here, if you put r is equal to 1 here, then what you're gonna have, you're gonna have this r plus 2 will be 3 now, because r is equal to 1. Then here if you put r is equal to 1, then m minus 1 into m minus r instead of r we are putting 1 here, minus 1, so it's gonna be minus 1 minus 1 minus 2, then divided by m minus 1 plus m minus 1, that's gonna be again twice m minus 2, twice m minus 2 into, if you put 1 here, m minus 1 and minus 2 is there, so m minus n minus 3, that's what we're gonna have, and this will be a1. Okay, a1. As you see here, we have a1 equal to 0, so that means this term will be equal to 0 on putting a1 equal to 0 here. Similarly, if you put r is equal to 3, I'm not talking about even, if you put odd values of r equal to 3, then you will get a4, sorry, not a4, a5, not a4, a5. If you put here r is equal to 3, then you're going to have a5, and a5, and there will be something into, then you will get a3. You're going to have, as we have got here a3 something, this thing into a1, so similarly we're going to have a5, we're going to have something here into a3. Okay, similarly in case of a7, we're going to have, here must be a coefficient, then into, we're going to have a5. This pattern, in this pattern we're going to get a9, a11, so on, right? And these terms will be 0, because here you see, as we are getting here a3, and I have already shown here a3 is equal to 0, so similarly this a5 will be also equal to 0. Okay, now as we have got here a5 is equal to 0, that's why when you will find a7 something into a5, then as a5 is equal to 0, then a7 will be also equal to 0. That's why we can write that a1, a3, a5, a7, these all terms are equal to 0. Okay, now let me copy this equation number 5 and let me go to the new slide. Let me take a new slide, okay, so that I can explain further. So let me write the equation number 5 here again. So here is the equation number 5, and we have already got a1 equal to 0, so we also can show that a3, a5, a7, these terms are also equal to 0. Now if you take the first case in the sense, as we have already shown that we have got two values of m, one is m is equal to n, another value we had got m is equal to minus n minus 1, right? So just give me a second, let me go back to that slide where we have obtained this. Here you see, not this one, here, equation number 4. So in equation number 4 we have got these two results, right? M is equal to this and m is equal to n also. Okay, now we are talking about this case. This is case 1, this is case 1, and this is suppose case 2. Okay, now let me deal with this case 1, m is equal to n, right? So for m is equal to n, for this condition m is equal to n, what we're gonna have, from equation number 5, from equation number 4, we have got this condition m is equal to n. Now using this condition in equation number 5, it becomes this ar plus 2 is equal to this. This is what we have got, right? So how we have got this? So what we have done here, just I have replaced this m by n, okay, then replace this m by n. So wherever you see m, replace it by n, because m is equal to n here. Okay, so then here also we have got n. Okay, so here also we have got n, here n minus n cancel, so we have got this, right? Hope you have understood this. So here we're gonna have minus r minus 2, and this minus 1 is taken common, that's why this minus is written here, right? Hope you have understood this. So that's why it becomes r plus 2. Okay, hope these things are clear to you. So now, so as we have already got a1 equal to 0, a3 is equal to 0, a5 is equal to 0. Now let us obtain let us obtain, you know, A0, A2, A4. So sorry, these are not equal. Okay, so let me obtain A0, A2, A4, A6 and so on. Okay, so in order to obtain those values, this A0 remains A0. Okay, we're gonna calculate it from A2. Okay, so if you put R is equal to 0, then what you're gonna have? So replace wherever you see R, replace that by 0. Okay, then you're gonna end up getting this term. So here I have put R is equal to 0, this R is also equal to 0, this R is also equal to 0, here also R 0, here also, sorry, not this one, here also 0, then this R will be also 0. So A2, here we have got A2, then here we have got A0, and that's what we have got, right? So now you see, okay, now let's put R is equal to 2 in order to obtain A4. So if you put R is equal to 2 here, it gonna give you A4 is equal to, so now replace all the R's by 2. Okay, so replace those by 2, then what you're gonna have? Then you're gonna have this result, right? So here A2. Okay, so here we have put 2, here also we have put 2 minus 1, that's gonna be minus 3. So here we have got n minus 3. Similarly, if you put here 2, then minus 2 minus 1, again you're gonna have minus 3 here. If you put the 2 here, then R plus 2 is 2 plus 2 is 4 here. Okay, so now you see, this A2 can be replaced by this value of A2 here we have obtained, and if you do that, then you end up getting this. Now you see, just let me clean these things. Now you see, if you observe the pattern clearly, then you can obtain, just observing the pattern, you can obtain A6 also. Putting R is equal to 4, we're going to have A6 is equal to this. So let me explain how we have got this. Just give me a second. Right. So I missed the A0 here. There's supposed to be a A0. So in this term also, not only here. Just give me a second. Okay, where here we should have a A0. Here you can see. Okay, so now you see clearly, this is minus n minus 1 when you have R is A2. In case of A4, it becomes, instead of n we have got n minus 2, n minus 3. Okay, then on putting this value, so now you see, if you observe the final results, A2 is equal to this, right? When we had A2, then we had minus n minus 1. So when you have A4, then n minus 1, n minus 2, n minus 3. So when you will have A6, then it should be continued to A5, n minus 4 into n minus 5, right? That is the pattern. Hope you can observe it, you can understand this. So now you see, here you can see clearly one thing. So this term, as here we have negative term, so that's why we have got negative here. Now as we have replaced A2 by this value, as there is again negative, so this negative, it becomes positive, right? So similarly, when you will calculate this A6, this A6 will be equal to negative of something into, you will get A4 here. As A4 is positive here, and we will have negative sign here, because the formula here, in this formula we have negative, in this equation we have negative. Because of that negative, we're going to have negative sign, as we had got in calculation of a4 we had got negative. Further it becomes positive because we have used the value of a2 which is already negative, right? So negative it becomes positive. Now here we're gonna get this negative because of this from this formula, from this equation. Okay, then again we're gonna have here a4 which is already positive, so we're gonna get positive value of a4. This positive negative, this terms remains negative, right? Hope you have understood this. So now again, if you see the pattern of the denominator, let me tell you the pattern of the denominator. Here you see, here we have got n minus twice n minus 1 into 2, and here we are getting 2 into 4. There was only 2, now it 2 into 4 when we have taken a4. So when we're gonna take a6, then we have to multiply here 2 4 and 6. Here you can see clearly. Okay, then here we had 2n minus 1, and here we are getting 2n minus 1, 2n minus 3. In the next term we should get 2n minus 1, 2n minus 3 and 2n minus 4. When you will calculate a8, then you're gonna have 2n minus 6 also. Okay, right? And this term will be continued till n minus 7, right? Hope you have understood this pattern. Okay, now let me use this results, okay, in equation number 2. Putting this results in equation number 2. So what was the equation number 2? Okay, let me go back to that slide, first slide, where I have written the equation number 2. Okay, here is the slide. You can see this is the slide, this is equation number 2, right? So now we're gonna use these results. We're gonna use this value of a2, a4 and a6 in that equation number 2. Okay, so here you see a0 remains a0, so a1 becomes 0. We have already shown a1, a3, those terms become 0. Then a2 will be replaced by this value. Here you can see this is a2. Similarly, here we're gonna have a3 which is gonna be equal to 0. Again we're gonna have a4 x to the power something. That a4 will be replaced by this value that we have got, right? Hope you have understood this. Now let me copy this equation number 2, and also let me copy these results a2, a4 and a6. Okay, these results, and let me write all those things in a new slide in order to explain further. Okay, so here you see I have written the equation number 2 again from the first slide. Let me go back to the first slide. So here you see from this slide I have written this equation number 2 from the very first slide. Okay, so now again you see we have already got these values of a2. Okay, so here you see we have already got a4, a2, a6. Okay, we're gonna use these values in equation number 2, this equation. Okay, in this equation. Okay, so I have copied this all values a2, a4, a6 and also this equation as well, this equation number 2 as well, and I have written all these things in a new slide. Here you can see I have written all these things in this slide. Okay, now we're gonna replace this a2, then in the next term we're gonna have a3, a4. A3 will be replaced by 0, a5 will be replaced by 0, a1 will be replaced by 0, then a2 will be replaced by this, a4 will be replaced by this, a6 will be replaced by this. So here we should have a0. Okay, I forgot to take write that. Okay, so a0, here it must be a0. Now this here also we have a0. That a0 will be taken common. Okay, then after taking those common and that a0 common, we're gonna have one more thing. We are doing it for the case m is equal to n, so we're gonna replace all the m here by n. Okay, this m will be replaced by n. Okay, so then what will be the result we're gonna have? That's gonna be equal to a0 is taken common. Now we're gonna have x to the power n. Instead of m we're gonna write x to the power n, then minus. Now here you see this a1 is equal to 0, this term will be 0. Now a2 is equal to this. Let us replace this a2 by this. A0 is taken common, So we're gonna have minus n into n minus 1 divided by twice n minus 1 into 2, right? And we're gonna have x to the power n minus 2 here, x to the power n minus 2. Okay, similarly if you put x3 is equal to 0, x3 will be equal to 0. Now let's put a4, a3 is equal to 0. Now let's put a4. So n into n minus 1, n minus 2, n minus 3 by minus 2 into 4, twice n minus 1, twice n minus 3, right? A naught is taken common, then we're gonna have x to the power m, sorry, not m, here we're gonna have n minus 4, then again we're gonna have negative term, then we're gonna put a6 and so on, dot 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 dot, so on. That's what we're gonna have. So this is suppose equation number 6, and this is the solution of equation number 1. This is one solution of equation number 1. This is one solution of equation number 1. Okay, in the form of series of descending powers of x, right? Because here power is decreasing gradually, right? So we can obtain the solution similarly for ascending powers of this x. Okay, you see we have done this for this case 1, which is equal to m is equal to n. Now we have to solve it for case 2, that is case 2 is m is equal to minus n minus 1. Okay, so for that case what we can do here, then we're gonna okay, so let me go back to the slide where we have got equation number 5. Okay, so we have already got one solution. This is one solution. Okay, for case 1 this is the solution we have got. We're gonna have another solution, another solution in the form of series of descending powers of x. Okay, so let me go. So this is equation number 5. Okay, let me copy this, and let me tell you one more thing. So I have made a mistake here. This is supposed to be n, okay, not m. Replace this by n. Go back to the equation number 5. This is supposed to be n. Okay, by mistake I have written m. Okay, so now let me copy this equation number 5. Okay, let me go to the new slide. So this is the equation number 5. So now case 2, what was the case 2 is m is equal to minus n minus 1 or minus n plus 1. Simply you can write that way. Just let me simply keep this way. Okay, that was from equation number 4. Here you see this is the equation number 4. So let me clean this so that you can see it clearly. So this is this result we have used. M is equal to minus n minus 1. Okay, so now if we replace this m by this m, then what we're gonna have here, you see, first let me write it roughly. A plus 2, so m is replaced by minus n minus 1. Here we have minus r, then minus n minus 1 minus r minus 1. Here is the numerator, and denominator will be of this kind, minus n minus 1 minus r plus n minus 1 into, again replace this m by minus n minus 1 minus r minus n minus 2. Okay, so here it's gonna be, you see, you can take minus from this term common, then these terms will be positive. You can take minus sign common from this term as well, then these all terms will be positive, right? Then this minus, it becomes positive. So n, sorry, not m, n plus r plus 1 into, here we have plus 1, so it's gonna be plus 2 n plus r plus 2. Then here you see plus n minus n cancel, minus 1, that's going to be minus 2. So minus r minus 2, on taking minus common, this sign will be positive. We have taken minus common. Okay, so similarly here you see minus n, that's going to be minus twice n. Then we have minus r here, then minus 1, minus 2, that's going to be minus 3. On taking minus sign common, this negative terms will be positive, right? And this negative becomes positive, right? So we end up getting that a r plus 2 is equal to n plus r plus 1 into n plus r plus 2 divided by r plus 2 into twice n plus r plus 3. That's what we're gonna have. Now let me clean these things. So we have got that a r plus 2 is equal to n plus r plus 1 into n plus r plus 2 divided by r plus 2 into twice n plus r plus 3. That's what we have got, right? Hope you have understood this. Now let me clean these things. Okay, so here you see, as I have already shown earlier, that values of a1 and a3, a5, a7, these all values are, these are all equal to 0 before dealing with case 1 and case 2. Okay, I have already shown this one before. Okay, so now for case 2, we are these values, values of this a1, a3, a7 will be 0 for both cases. Okay, case 1 and case 2. Before I have mentioned the case 1 and case 2, I have shown these values are equal to 0 before dealing with those case 1 and 2. Okay, I have already shown that. And then we have to find a2, a4, a6. So these values for case 1 and case 2 separately. For case 1 we have already done, we have already got the solution as well. So now let me find it for case 2. Okay, what will be the value of a2, a4, a6, so on. So now let me find that. Okay, so in order to get a2, let me put r is equal to 0. R is equal to 0 in order to get a2. So a2, so wherever you see r, so replace that r by 0. Then what you're gonna have, you can have n plus 1 into n plus 2 divided by r plus 2 means simply 2 only. Okay, then twice n, this r is now 0 plus 3, that's gonna be 3. Okay, that's what we're gonna have. And we're gonna have, sorry, I missed that ar here. So as we are putting r is equal to 0, so it's going to be a naught here. So similarly, let's put r is equal to 2 now. Don't put 1, okay, because on putting 1 we're going to get a3, which is equal to 0. Already shown these things are 0. Okay, so on putting 2 we're going to have a4, and if wherever you see r, that's just to replace it by 2. Okay, just to replace it by 2. Then doing so, what we're going to have, we're going to get a4 is equal to n plus 3 into n plus 4 divided by 4 into twice n plus 5. That's what we're going to have into a. Now r is 2, so a2 we're going to have. Now replace this a2 by this value. Okay, as we have already calculated a2. So doing so, what we're going to have, we're going to have a4 is equal to, so n plus 1 into n plus 2 into n plus 3 into n plus 4. That's what we're going to have, divided by in the denominator 2 into 4 into twice n plus 3, then twice n plus 5 into a naught. Similarly, you can find a6 also. If you observe the pattern, here you see we had got n plus 1, n plus 2. For a4 we have got we have started from n plus 1 and we have ended at n plus 4. So here we have to start it from n plus 1, then the last term will be n plus 6 for a6, right? And here we have got 2, here we have got 2 into 4, here we're gonna have 2 into 4 into 6. Okay, then we have to start it from 2n plus 3, then it's gonna be ended with twice n plus 7, right? 7. When we have n plus 4 here, it was twice n plus 5. So when we have 6 here, it's going to be twice n plus 7, right? That's the pattern. Hope you have understood this. So that's how we can obtain this kind of terms. Okay, now here you see, let me write here, so on. Okay, now we're going to use this value again in equation number 1, sorry, not 1, in equation number 2, the solution that we have considered. Okay, so now let me rewrite the equation number 2 in a new slide. Okay, and let me use those value as well. Okay, just give me a second. Now let me copy this equation number 2 again, this equation. Okay, so that I can simplify, so that I can obtain the solution of the equation number 1, that means the Legengre's differential equation. Just clean it in order to copy this correctly. Okay, so here is the equation number 2. So let me take, this is y is equal to this one, this is the value of y, or you can say equation number 2. That is what we have considered, right? And what are the values? We have got a1, a3, a5, these are equal to 0, these all are equal to 0. We have already shown this, right? Now what was the value of a2? Let me use this value here from previous slide. Let me copy those results. Just give me a second. Okay, so we're gonna use these results. Okay, so just give me a second. So here you see, okay, these are the values of a2, a4 and so on, right? So here you see, what we need to do, we need to write here that using these values in equation number 2. So if we use these values in equation number 2, so what we're going to have, we're going to replace this a1 by 0 because a1 is equal to 0, a3 is equal to 0. We're going to replace this a2 by this value of a2. Similarly, we're going to replace a4 by this value, right? Okay, and using this value in equation number 2, this result will be of this form: y is equal to a0. A0 is taken common. Here also we have a0, here also we have a0. From all the terms we have taken a common, a0 common. Then here m is equal to minus n minus 1. So what we're going to do, we're going to replace this m by minus n minus 1, and that's why we're going to have x to the power n minus 1. Then this term is 0. Then we're going to have plus, let us put a2, which is equal to n plus 1 into n plus 2 by 2 into twice n plus 3. Then we're going to have x to the power minus n. Now here if you put m is equal to minus n minus 1, that's going to be minus n minus 2, and if you put minus n minus 1, then n minus n minus 3, right? Then in the next term, a3 will be 0. Now put a4. a4 is n plus 1 into n plus 2 into n plus 3 into n plus 4 divided by 2 into 4 into twice n plus 3 into twice n plus 5. Okay, then x to the power minus n minus 5 plus dot 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 so on. That's going to be the result. Okay, this is another solution. Okay, now let me cut this number 2. Okay, this is another solution of equation number 1. So this is another solution of equation number 1. Similarly, we can find the solution for that equation number 1, Legendre's equation, differential equation, in the form of a series of ascending power of x. So in order to get that, what we're going to do, just let me go back to the first slide. You see, in this case, in order to find the descending powers of x, we had considered here m plus r. That's why with increasing increasing value of r, these powers will be decreasing. Okay, so similarly, in order to obtain the ascending powers of x, we're gonna put here m plus r. That's it, and the procedure is same. Similarly, we can find it. So hope you have understood this, right? So thank you for watching. See you in the next video. Hope this is helpful.